Hey yo, well yeah, this is the lesson for day 4 on data analysis. We're going to be studying box plots. Guys, these are just more generally known as box and whisker plots. It'll make it easier for you to understand, so if you just call it this, box and whisker plots. All right, so let's just jump right in. A box and whisker plot is a graph that displays data on a number line using 5-number summary. And I kind of went through all this before, so excuse any of the scratchings that you see. Okay, by dividing the data into quartiles, that's Quartiles. Each section of the box and whisker plot represents 25% of the data. So you think 4 quarters makes $1, each quarter is 25 cents. It's the same concept here for whoever doesn't understand that. 25% times 4 is 100%. Okay, box and whisker plots show the distribution or spread of the data. Spread of the data. It does not show individual data points. Does that sound familiar? It should. Right? So when we were looking at histograms a few days ago, these were in intervals, small chunks that also do not show individual data points. See up here? When looking at a histogram, individual values cannot be determined. So it's the same thing here, guys. It's just a different way of depicting the data. So let's get into an example. To create a box plot for a set of data, you must find 5 values for the data. So that's what this is, 5-number summary is talking about. So you'll say, to create a box plot, 5. Okay, so first I find it easiest to map all of your values out. So I see 16 here. I don't think this problem actually gives us a raw set of data to work with. So I'm just kind of using their end result box, which is kind of cheating, but we'll at least get the okay. So when you list out all your data, give me 1 second. Actually, guys, I'm just gonna zoom through this and we'll have a better idea down here. They don't give us a raw set of data to work with. They just kind of give us a finished version of the box and whisker plots, which I could work backwards and ascertain, like, okay, 1635, obviously, and then I could do some other work, but let's just skip through the definitions really quick. Your first step is, though, to look for the upper and lower extremes, right? So 16 and 35 are this one. And that'll be, lower extreme is the smallest number in the data set. And for their data set here, it's going to be 16. The upper extreme is going to be the largest number in the data set. So that's going to be 35. All right. The next easiest thing to do is to find the median, which is the middle number of the data set, which we reviewed in measures of censor yesterday. So that's the middle number of the data set, and it looks like their middle number is 19. No, 26. Yes, I was looking at the lower quartile. Yeah, so 26. Okay, once you find the median, and remember, if there are 2 numbers in the middle, a median is just the middle number in the entire data set. And I can just kind of, since they don't give us anything specific as far as like the raw data goes, we'll just say lower is 16, upper is 35, obviously. I can see that 15, 20, 25, 30, 35. Okay, so 16, I'll just say, you know what? No, I don't want to steer you wrong, because these are the only two that I know for sure without doing any extra work. So the lower quartile is the median for the lower half of the data set. And for this one, it'll be, this is what I was mistaken earlier, 19. The upper quartile is the last thing that you want to find, is the median of the upper half of the data set. And it looks like theirs is 32. Okay. All right. So let's get into an actual example. I'll do this whole thing actually on here because this wasn't the best example. They don't give us any like things in terms of raw data that I can see. So how to make a box plot. You want to start off by ordering your data points from least to greatest. So let's just do this as we read this. Terrence asks some friends to pick a number between 0 and 10. The results are shown. Create a box plot for the data. Okay, so I see step 1, order your data points from least to greatest. So that's going to be, I see my smallest number here is 4, I think. Yeah, no, 3. So I'm going to say 3, 4, 4, 4. I see 2 5s. I see a 6. I see 2 7s. I see 2 8s. And I see a 9. All right, so this is all my information listed out in order. Step 2, find the lower extreme and the upper extreme. Okay, remember this is the easiest thing to find. Lower extreme is equal to 3. Upper extreme is going to be equal to 9. The median, so find the median of the entire data set. That's just the middle number is equal to, count in. I see 5 and 6, so the median is going to be somewhere in here, which will be 5 plus 6 divided by 2. So that's going to be 11 divided by 2, which is equal to 5.5. And I'll let you work out that long division on your own in your composition notebooks if you want. So your median is going to be 5.5. Now, this is where it gets fun. Find the lower quartile, Q1, by locating the middle number in the lower half of the data, right? So, okay, don't forget to, so this is what we're gonna say for the median on the lower quartile. This is the lower quartile, the first 25%, right? So see what I just did there? I almost accidentally omitted my 5. Don't do that. Include your 5 because your median is in between the 5 and the 6. So that means the 5 is a part of its own quartile and the 6 is a part of its upper quartile. Okay. So the lower quartile is going to be, you're going to include the 5. So between the 5 and the 3, 5 and the 4, I see 2 middle numbers. 4 plus 4 is 8 divided by 2 is 4. So the lower quartile is equal to 4. And I'll just write it out. 8 divided by 2, which is equal to 4, right? The upper quartile, 1 and 6 and 9, 7 and 8. I see 2 middle numbers here. So it's just like you're finding the median 3 times in the entire data set in the first quartile and then in the second quartile. Technically, this is the third quartile that you're finding, right? Because you can see up here, Q1 and Q3. But just for clarity's sake, we can just call it the lower quartile and the upper quartile. That numbering kind of confuses me sometimes. But anyways, the lower quartile is for the upper quartile. Try to squish this together, guys. We're about to draw a box, and I did not leave enough space. So I'm just gonna move this information over here. So while we work in pencil, so we can say upper we can say lower quartile is equal to 8 divided by 2, which is equal to 4, right? And then the upper quartile is equal to, let's see, 15 divided by 2, which is equal to 7.5. All right, so we have our 5 numbers: lower extreme, upper extreme, median. We have the lower quartile, and then we have the upper quartile, okay? So now that we've done that, plot these 5 values on a number line. The lower and upper quartile create a box with the median designated, and then the upper and lower extreme are whiskers off the box. So all this step 6 is saying, guys, just plot these out. Lower extreme is 3, so we're gonna put a dot up here. That's 3. The upper extreme is 9, that's up here. The median is 5.5, that's like about right here. The lower quartile is 4, that's like right here. The upper quartile is 7.5, that is right here, okay? So this is how it works. Just draw a box around the upper and lower quartiles, right? And enclose the median. So trap the median in a box. Your median value was 5.5. So the median value for the whole data set gets trapped in the box created by the lower quartile and the upper quartile. Then your whiskers come in here. Your lower extreme up to your lower quartile and your upper quartile up to your upper extreme, okay? This is the box and whisker plot. And basically this is useful in determining average performance in, like, just for a real world example, like basketball or sales. Like if Jordan were to score a number of points, like let's say this represented points that Jordan scored during, in a span of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 games, right? So in 12 games, his lower extreme was 3, his upper extreme was 9. It's not realistic to expect Jordan to do his best or his worst on every game. So it's best to draw this graph out, this box and whisker plot. So it's best to do that and then look at this box. And then in this box, you should be able to see his average performance. So this is, so I can in good faith now say that on average during a game, Jordan will score between 4 and about 7.5 points or something like that. And for you guys, also draw a line through your median here. I forgot to mention that. Just draw a line through your median, and then that's your entire box and whisker plot done. So yeah, it's just used for basically determining averages or average performance of something or someone. And yeah, I hope that example was clear enough, the basketball thing. But this is getting kind of long, so I'll end it here.